Hello, everyone. Welcome to part two in this topic six, which where today we talk about digitization and digitalization. So nowadays we hear a lot about digitalization of systems, digitalization of services, digitalization of industry, and so on. So let us explain what is the digitalization process and what is the digitization, what is the difference between them. Okay, so actually, digitalization is services or operations that are based on digitization. So the digitization is the process to convert like anything into digital format. When it becomes digital format, then we can read them by computers. We can store them like 0 and 1. 0 and 1, what it means that there is electrical current or no electrical current. So it is the way that our like electronics can deal with, and we can understand them, and then we can build some logical operations like AND operation, NAND operation, NOR operation, and based on this logical gates, we can build like memories. We can build higher operations of like summation, multiplication, and many other kind of operations that can be represented in digital format. So this what gives the computers this like very effective way to deal with the data. Okay, so one example is if you have let's say bills. So you have bills from for some like your rented house bills or whatever. So you have a lot of papers in your house. Okay, so those are in material format. Now you decided to have a picture or scanned every bill and put them in your computer. Okay, so this what you can do. So making scanner or using your digital camera or your smartphone, then you can convert them into digital format. Now you have them into digital format. You can save them in the computer, or you can save them into your flash memory. Okay, this process is called digitization. So you digitize your material papers into the digital format. But this is not digitalization yet. So this is a digitization process. Now, if you build any service based on this digitized data that or numerical data that you have, or binary data that you have, if you build service, for example, one kind of service that you want, for example, when you have a new bill, then your system will tell you that what is the average of your bills, or the delay, or gives you some reminding, because they can see the sequence of the bills. So they expect that the next one should be at that time, or whatever, any kind of service that you can think about. So now, once there is action based on this digitized information, then it becomes digitalization. So we have digitization first. The first thing that we convert the material into digital format. Then we have the digitalization algorithms. Based on the digitalization algorithms, then we will have services provided to people. If we, for example, some person that we record all his health data into computer. Now this is digitization. It is not digitalization. It is digitization because we have all data into computer. But if there is like follow up, or there is some call, or there's some analysis of this data, whatever that we can build over this saved data, then it becomes digitalization, is using of this digitized data, and based on that we can build services, as we can see today, like many social services or governmental services that we have, and many other things. It makes life much easier. So this is the digitalization process. And for example, nowadays, what makes this digitalization process feasible? If we now see one integrated circuit, it is not I mean, it is used for commercial application, is for example M1 Max from Apple. And in this processor, it contains 50 billion transistors. And before just 50 years, in 1972, the maximum number of transistors per IC for commercial application, I mean, it was Intel 8008, and it has only 3,500 transistors. So you can see that the number has been increased 15 million times. So you can see, of course, this is not just an increasing in the number of transistors, but it means increasing in the capability and the applications of these ICs can do. So this can give some indication why now, why digitization, machine learning, artificial intelligence, why they have been started just like 15 or 20 years ago. Why not before? Even the mathematical foundation is almost the same. Okay. So this is actually the digitalization process. So you can think about, so in this forum, so you can see that we have objects, or we have material or social system or whatever. Always we can convert them into by using the digitization based on sensors. For example, we have sensors, you have scanners, you have camera, you can read them from Facebook, data from Instagram, whatever that you have collecting data. So all the time you are collecting data. We have data collections and measurements, sensing, whatever. So of course, over every data collection, we have bias, we have noise, we have disturbance. So we have to take this into account. Usually we don't have pure information. We are collecting data. As I mentioned the previous part, that data can be biased and noisy and corrupted, incomplete, whatever. Okay, now we collect this data. Based on the collected data, of course, we can have like data processing, data fusion, data mining. Okay, and then we can of course store the data, or we can recall the data. Then data is used with the information extraction. Here we have the machine learning, mainly machine learning, we have them here. Also in data fusion, data mining, we can have it as well in this part. So we have data extraction based on information extraction, and from information extraction we can have like knowledge, and we can build our knowledge or enhance our knowledge, and we might have new theories. But it is possible also that we can feel that there is some missing thing, so we can ask in this feedback to collect more data, or to have like some new kind of data. That, for example, for certain process, we thought that based on the knowledge that there is something missing to complete the model. So we might ask, for example, the temperature, the sensor that we want temperature sensing data, or we want, for example, the location data, and so on. And also this knowledge can be used for the data processing. So we can have in the data fusion or data mining, sometimes we ignore some kind of data, but we say that no, this data can be useful. So we try to also to extract it. Okay, and in the information extraction also we can have we can build optimization here, and also from the output from the theory can we go to the optimization, and from the optimization of some system, for example, we can build a decision maker. In the decision maker, it takes into account that the possible risks as well, and the decision maker can be human and can be also automated, as we will see in topic 8 in this course. In topic 8, I will talk about game theory and how game theory will construct this or enhance these decision makers in intelligent agents. And after that, we have the actuation or the actions. We have actuator or actions or input to the system. So the input here to the system might change the environment, and when this change the environment, then we can have this loop again. So this is very abstract way to look to the digitalization process. Of course, not every digitalization we have every block there, so we might have some of them, might not all of them actually, and then we can see this as a feedback of the system. Okay. Yes. Then the question again, why now we have we see this artificial intelligence and machine learning? As I mentioned, the main reason is the fast development in telecommunication, mainly in wireless communication, and also in computing devices. Those are the main technological reason. The third reason, of course, is the needs. So these developments with this also like increase in number of population, and also the lifestyle right now that we need to do things faster and also in more efficient way. So this builds these new requirements for many services. Okay. So the concepts actually of several algorithms, as from mathematical point of view, they are well known. Some of them they are well known like 70-80 years ago. Some of them like 6 years ago. When we talk about least mean square or these algorithms, they are from mathematical point of view, they are well known for decades. But from technological point of view, it was the lack actually between the application and why we don't implement this AI and machine learning before. To give just example, before 20 years, about 20 years, in 1999, 1998, the wireless data rate was about 9.6 kilobit per second. We were using at that time data over GSM. So at that time it was 9.6 kilobit per second, and after that they enhanced it to, if I remember well, 14 point something kilobit per second, but it was still that very like slow. But now, within 20 years, the data over your mobile phone can be up to 1 gigabit per second, which means that 100,000 times. So this is for commercial application. So we have achieved 100,000 times faster. So now you can think that data can be transferred now. It can be transmitted like very fast, almost in the same moment. When this happened, maybe just a few milliseconds difference, and you can send them from any location to any location. So the availability of data, the fast data, the availability of data makes new services that we can build new services based on this data, and this data is huge, and also the computation capabilities. So nowadays your mobile phone, it has like a computing device which is like maybe hundreds or thousands of times more powerful than the laptop like before 30 years, for example. So if we talk about the peak computation, the most powerful computation capabilities during the last 60 years, now our supercomputers are more powerful more than 100 million times. So you can see that this computing capabilities, communication availability, the distribution of and the availability of inexpensive sensors everywhere, the explosion in data. So we have a lot of data, we have huge data, we have new services, applications, and so on. So all these things are like harmonized in a way to make this new nice applications. And by the way, we are still in the beginning of this era of AI and machine learning. So what is machine learning? As from the name, so it is related to the technologies of how to make computing devices be able to learn directly from data and to make reasonable output. For example, in terms of modeling, suggestions, conclusions, and even decision making. So it is the core of what is called data-driven systems. This is the machine learning. The application of machine learning are vast and in many different areas. So we will see many different applications later in this part. Just an example about this the capability of machine learning. Just think that you want to analyze the data coming from 20 million mobile phone in a big city. So if you have a track of if in certain city they are tracking 20 million mobile phones, how is the like the dynamics, the patterns of these mobile phones, and how they are like of course the mobile phone is carried by people, and how people it gives you some indication the dynamics and mobility of people. So if you want to look to them, it is almost impossible to be done by human, and also by slow computer. So you want to track 20 million mobiles in real time. So you can see that what we need here. Yeah. So let us have another example. If we want to observe people reaction according to some specific international event. Nowadays, everyone talk about Ukraine war, for example, or shortage of energy and so on. So, for example, if we decide to use 100 million Facebook account just to see the people reaction against the world, against the war, against energy issues, against these like hot topics today. So we are collecting data. So we check these Facebook accounts, and then we can collect the reaction in terms of written text. Of course, we check some keywords there, emoji, pictures. So the machine learning can build a reliable model, or we can build knowledge based on responses. It might use some keywords to catch the trend of the post. So the person's age, country, city, gender, job, degree level, marital states, friends and friends of friends, and so on. All these data can be collected as well. So the model actually, by the way, we have to take into account that some Facebook accounts that they are, for example, fake accounts. Some of them they are based on some bots, so they are not real accounts at all. Some people they use like fake names, fake age, for example, not real pictures, and so on. So this is like junk data that we have, or we have some biased accounts and so on. So all these things should be taken into account by the machine learning when they are extracting or building some information. What is the dangerous thing here? The dangerous thing here that based on such kind of information collected or data collected, and we build the model, then the machine learning with AI could try to like see the responsive people by, for example, showing some fake news, for example, and to see how is the response, and based on that they can also build or increase the accuracy of the model. And also they can present some information which is true information, but they presented them in the way to like change or mislead the people. So even the way that how to present information can be sometimes very critical. So all these things actually they are very sensitive, and about people now talking about like social or society engineering, or maybe reformulate the general trend of societies and so on. So this can be actually one of the dangerous application of machine learning and AI, because they have now accessibility to everyone. So we can have also personalized response. We can have just misleading information or mispresented information sent to person per person. It is on a personal level, even not in the trend level, and this is available with this machine learning and AI, with this availability of data. So things can be, of course, can be used in the right path to have like much better health system, much better energy efficient energy application, and so on. But it can be also used to rechange the ideologies or redirect the ideology in certain direction and so on. So things can be very like sensitive in these applications. Yes. So we can have another example that if you want to build, for example, a machine learning this is one of the good application of machine learning that can be used to differentiate, separate the mixed contents of a huge waste resorting. The process is important for the recycling because of this waste material that we can extract the different material together, like plastic together, wood together, and so on, for the recycling process. So people can do that easily, but actually for a computer with a camera, it is not that easy. So we need all the time to have such kind of AI, artificial intelligence, and then when they made mistake, we show that this was mistake. So for example, if they collect one plastic as a wood, then we tell the machine that this was wrong, and after that they can also learn from their faults. So the machine can itself increase its experience when they are working in that. So we have one YouTube. I found it on the YouTube channel to show this process, and you can find this here. But let me play this video to see how it works. Yes. Yeah. So sorry for the skip. So this was just a short video to see how this machine learning and with the intelligent system and camera that they can be used for such kind of applications. Yes, and of course we can have also many different applications about this machine learning, and based on definition in expert systems, they say that machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So this usually machine learning algorithms, they are general. So it depends on data, regardless of what this data represent. Is it image? Is it data of health system? Is it data coming from this waste machine? Regardless what is the data. So it is at the end of the day, it is just data. Of course, there are some processing based on the nature of this data, but at the end, the machine learning algorithm is general. So when we talk about neural networks, for example, they can apply it for many kind of applications. So we don't design the neural networks specifically for this application, but you can have the structure of the neural networks based on specific kind of applications. For example, the number of neurons, the number of hidden layers, and so on, as we will see when we talk about machine learning in the next topic. So machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. So the machine learning actually is based on algorithms, and those algorithms can be like computer codes based on mathematical and statistical concepts. So they are very important. We have a course in our university is a machine learning course where we give the details of mathematical and statistical concepts, the algorithms, mathematical foundation of machine learning. And we have another course is called Applied Machine Learning, where it is more like programming oriented, where the students see how to apply those algorithms using Python, or they can use also other kind of programs. But mainly Python is used in that Applied Machine Learning course. Okay. Let us see some machine learning and how it is used to reduce uncertainty. So usually we have process, and this process we are looking for some hidden information, and you can see that we have high uncertainty about this hidden information. Let us talk examples. For example, if you have email, and this email can be like spam or a real email. So how could, of course, if you are working and you receive many emails, like me, for example, I receive on the average like 20-30 email per day, and most of them, they are important. So they are, some of them they need like direct response from me. Some of them I need to like postpone the response. Some of them they remind me about something that I need, for example, a review paper that I accepted to review it, and I need to send my like comment about the paper, and so on. So I received 20-30 emails. Many of them also, they can be like announcement about conferences, about a new journal, a new books, many emails from students, master students or PhD students. Some students, they want meeting time. So I receive 20-30 email, between 20 to 30 email per day. But above that, I receive also like 20-30 junk emails. I used to have, now not anymore, and thanks to this new or this AI based spam removers. But we used to have also 20-30 email, maybe sometimes more, of those spams. And those spams actually makes it difficult to reach to the email that you are looking for. So in the same time, this intelligent spam remover that you want them, or junk remover, they want them to be accurate enough that they don't remove some important email. Okay, now the spam remover, they are based on some keywords looking, for example, to the subject or to the email itself, and based on that they decide is it spam or not. Okay, and also it can be customer. For example, if you are in bank, you are bank manager, and there's a customer came and they want to have like investment. They want loan, let's say 100,000 euro, and they want to invest them in some like project. So what is the risk of that customer? So it is something hidden that we don't know. There's a high uncertainty. So if this is a new customer, should you as a bank manager or as a decision maker, should you agree about the requirement and give him or her the required support or not? So now we need to have, of course, you cannot have an equation based on that. You can use your sense, but sometimes if the customer like complain, how can you explain that you have this decision about just based on your sense? Of course, you can claim anything else, but still fault. If there's a system where we have like big like smart grid or some electrical grid or some big factory, and there's a fault happen on your car or so on, how can we find the reason of this fault, the real reason for the fault? So the fault allocation, it is something hidden. Okay, the faster you allocate the fault is the minimum risk and minimum cost. Risks as well. So do you take this step or not? Do you want to buy this item or that item? What is the risk of buying this over taking that? So it's something hidden as well. So we have uncertainty about all. This is just a few examples. Okay, but we might have some database, and this is the key thing of machine learning. You have database, and based on the database, okay, you can build some machine learning algorithm. And because we are living in a world where there is similarities, things are correlated. For example, if this spam remover AI agent, they start to look for like hundreds of thousands of users, and once you find your email, one email as a spam, then you make just your like right click of your mouse, and then you say that it is spam, or move to spam folder or to the junk folder. Okay, now your AI learn from your action, and you learn from your action. So they have database, but it is from your action, not only your action, but this AI remover is for example is a system working with thousands of people. Then they start to build database about the keywords there, and those are removal. And for those which the AI decide to remove them to junk, and you go to the junk folder and you make the right click of your mouse and you move it to inbox, then also they make that this was not junk. And based on this a lot of data that available, then the machine learning algorithm can extract what is the most likely to be junk email or not. The same thing happens with customer. So if you look to the database of certain of all bank branches, and then they have some like some customers they were not trusted, and some other are trusted, and based on the attributes they have, what is the age of that customer, what is his education level, what is the account balance that they have, and all possible information about each customer, then the machine learning could give you suggestion that this person is 0.8% or 0.8 probability 0.8 or 80% that is cannot be trusted, or maybe only the 80% can be trusted, and so on. So this can be given by the machine learning. Also in the fault allocation, the machine can suggest where is the fault, as we explained before when we talk about the Bayesian classifier. Okay, so Bayesian classifier is just one application, of course. We have many other algorithms based on either statistical or linear algebra. By the way, for machine learning is founded over two major, beside, of course, the coding itself. The coding is just the implementation, but for mathematics, it is based on linear algebra and the statistical analysis or stochastic process or probability theory. Okay, linear algebra, probability theory, and the third one is the optimization. So all these three, they are representing the foundations of machine learning. Here we can see the system modeling, how it was. Here is human-based modeling. A human-based modeling is based on observation. So this is a real system. We have data, and we use abductive reasoning. We think about this data. We put assumptions, and based on the assumptions we put our mathematical model, for example. Then we come to the validation. We take the data, we put it to the validation. We check if the model and the real data give the same output. If not, then we go back and we rethink again about the system itself. Actually, too many modeling techniques was based on this idea. For example, if you look to Faraday's law or Maxwell's equations, or most of the physical Newton laws, actually many theorems that we have today is based on human-based modeling, which is in this way. Nowadays, with this machine learning based on modeling, the things can be different, because here we have a limitation. The limitation here is, for example, the accuracy of the model that we obtain, and also we cannot have every single effect. So if this real system is affected by thousands of items, then it might be difficult for the human to build a model or accurate model. It is not difficult to build any model, but to have very accurate model can be difficult. So in this case, we can have the machine learning. So you can see here that we have the real data. The data is coming not to the human directly, but it comes to AI and machine learning. Then the AI machine learning, they build or they suggest some model, and based on that, they have this validation. If the validation is not is bad, then the machine learning can change its structure or its size and so on. And then this loop will continue until we have a good model. Once we have good model, then we have the human here to make interpretation of this model, and they try to start building services and applications over this result. AI and machine learning. So as I said in the beginning, so machine learning is part of the AI. So the AI you can see here in the green circle. So we have the AI, which is quite general, artificial intelligence. Inside this artificial intelligence, we can have the reasoning, optimized strategies, imposed restrictions, finding solutions, payoffs, criteria, game theory, whatever that you have here. And we have the machine learning here. So what is the rule of machine learning? The rule of machine learning is to extract information. From where extracting information? From data. From where data comes from outside. So we can have social network, we can have sensors, we can have databases, and then we have data, big data or massive data, and this data is coming to the machine learning extracting information based either on supervised learning or non-supervised learning, and then we have classification, clustering, whatever, and then it gives the information to the reasoning and optimized strategy in order to take actions, and those actions goes to the applications. And then we might have externally the tuning and setting of this AI. So you can see here the artificial intelligence is general definition, or it is the umbrella which contains many other things like machine learning and game theory. Possible applications of machine learning. So you can see that here in data mining, banking process, fraud, spam detection, stock market analysis and prediction, manufacturing process optimization, like autonomy machines, like autonomous car, for example, medical diagnosis and drug manufacturing, smart health, smart systems like smart grid, smart cities, telecommunication network analysis and optimization, like what will happen in like 5G and 6G networking, security application, pattern recognition application, biometric recognition, optical character recognition, moving target classification, forecasting, robotics. Just few examples, and just name it as they said. So in machine learning, it might have many applications, and as I mentioned that we are still in the starting of this era of AI and machine learning. We are in this just in the beginning. So what is coming will be much more, and what we hope that the applications will be for the benefit of a human. Of course, in the next topic, we are going to talk more about the machine learning and the classes of machine learning. But just to give here a general picture, that machine learning can be classified into 4 major classes. Unsupervised learning. In unsupervised learning, we don't have what will be the result. So the machine learning will try to cluster the data, the available data, they cluster them. But after that, we use some interpretation why they cluster the data into these islands. What are the common between these islands? So clustering means that we are looking for some hidden similarities between data, and we try to island them or clustering them. Then we have here semi-supervised learning, where the data is not all classified, or we don't have what will be the result of all data, but we can build it some algorithms based on the statistical trend of the data, and also using part of the data is labeled, that we can use them. Supervised learning when we have all data is labeled. So we have data, for example, this email is junk, this email is not junk, this email is junk, this is apple, this is orange, this is apple, this is orange, and so on, this is cat, dog, and so on. Like dangerous, not dangerous, this is dangerous. Maybe the machine is close to it will be almost probably will have fault within 1 month. This based on this data, it will have fault within 2 months. Within this data, it most probably that they have fault within 1 year. So we have label. Once you have label, you can build some learning based on the supervised learning. And reinforcement learning, when we don't have data, but we want our machine or our robot to learn by itself. So, but how to do, since we don't have data to learn, we can have like critic. So we say that any action taken by this reinforcement learning, we look to at the end. If they achieve the objective, then we give them plus. And if they didn't achieve the objective, then we put punishment minus. And based on the plus and minus, the machine itself try to build its own information, extract its own knowledge, that without presenting any like teaching data or any labels. And those are the four main algorithms for machine learning. And then, for example, in supervised learning and reinforcement can be used, for example, for classification. It can be used also for regression, and the same as regression, but or the same as classification, but for non-labeled data, we call them as clustering. Okay, and here we have many algorithms. Actually, they applied for any of them, and most of these algorithms are given in details mathematically in machine learning course, and also they applied in the applied machine learning course. Yes, this is just explanation what I have said now. That is all for topic 6. So you can see that topic 6 is not mathematical based, it is just descriptive topic. And I hope now that you have at least some general idea when we talk about digitalization or about digitization, and when you hear data, you hear information, you hear knowledge, and you hear about machine learning, about artificial intelligence, the relation between AI and machine learning. All these things have been described in very briefly in this lecture. Thank you very much, and see you in next topic. Bye.